Alright guys, on exercise 17.9 it changes up its pace a little bit. It's a little bit different. It's asking you to calculate the delta S of the surroundings at the indicated temperature for reaction experiencing each change in enthalpy. What is this saying? Well, the good news is, algebraically, this is a very simple problem to solve. This formula is given to you as the delta S of the surroundings is equal to the negative delta H, which is enthalpy, divided by temperature. Now remember, guys, this negative value is always forgotten. People think it just goes away. Do not forget. Ran out of space there, but that should be a T. Anywho, so you can't forget that value. It's very important. So let's just do this problem now. So it wants us to find the delta S surroundings with this part A. Delta H equals negative 271 kilojoules and 298 Kelvin. Well, let's see. Delta S, is in joules per Kelvin, right? So we have to convert this value right here to joules. So why don't we just go ahead and do that real quick. We have negative 271 times 10 to the 3 joules equals negative 271 kilojoules. So that's out of the way. This is the value we're working with. So let's set the problem up. Delta S equals the negative value. Now, remember that negative. And now we have negative 271 times 10 to the third. 271 times 10 to the third divided by the 298 Kelvin, right? Now, I did this in blue right here. So I want you guys to remember this value. So we have a negative times a negative. What's that going to equal? It's going to equal a positive. So what's this going to be? When we do the math out, I got a value of 909 joules per Kelvin. Alright, let's look at this next problem. Well, we know that sorry, I apologize. I wrote write the formula back out. We got delta S for surroundings equals the negative delta H divided by T. Again, emphasizing that negative. Alright, so let's look at this formula while we just set this up. We know that we have to convert this value right here. Right there. So we have negative 271 times 10 to the 3 joules equals negative 271 kilojoules. So we have this value, this formula, delta S for surroundings equals the negative value of negative 271 times 10 to the 3 divided by the temperature in Kelvin. Notice we have a different one than before. So let's do this math out. I got a value around 3500 joules per. I don't know what that was. Let's just rewrite all that. I don't know why I keep trying to write an E. Now, look how drastically temperature plays an effect. Before, remember, when we had the same enthalpy reading, but different temperature. The temperature last time was, I think, 298, and now it's 77. Look at the drastic difference. Before, say with, what was it, 298? It was 909. With 77, it was 3500. It's important just to understand that and take a step back every once in a while and look at what plays an effect rather than just plugging and chugging and throwing in the numbers. One last one here, so we could probably do this one quick now since we did this. We've been getting better at this. Equals negative delta H divided by T. Again, that's a negative. Sorry. Anywho, let's do this math. We have to convert 129 times 10 to the 3 joules equals 129 kilojoules. Now, it's interesting. Now we have a positive enthalpy reading. So how's it going to affect our answer? We have delta S equals negative 129 times 10 to the 3 divided by 298. When you do this math out, I got a value of negative 433 joules per Kelvin. Exercise 17.13 brings up yet another way of problem solving. So Gibbs's free energy, what is that? Well, whoops, we'll be learning. Professor Quas will be going over this in class Wednesday, apologize, Tuesday. So if you are watching these videos ahead of time, you may maybe look confused, but it's not too hard. Gibbs's free energy formula looks a little something like this. Gibbs equals delta G equals delta H minus T times delta S. So let me rewrite that a little bit because that looked bad. Delta H minus T times delta S. So obviously temperature plays an effect here with the entropy, as we all know. So let's do a quick little review. We know that when delta S is positive, it's spontaneous. Now, when delta G, what's delta G? Say delta G is positive, is it also spontaneous? No, because of the algebra plays out when delta G is negative, it is spontaneous. Alright, so let's do some math. We have over here, it says delta H is negative 129, delta S is 246, right? So let's get some units down. I like to convert the enthalpy into joules, but you guys do whatever you feel is best. If you want to convert the other way, but we'll just do it out. We got delta G equals minus 129 times 10 to the 3 minus temperature in Kelvin 310 times 246. Right, so let's see, we have this right here. This is enthalpy. That we have right here is entro. And right here is just the temperature. So all the things we've learned are all starting to come together now, right? So when we do the math out, I got a value of negative 205,000 joules. Now I believe the answer wants it to be in kilojoules, so we got a value of negative 205 kilojoules. Great. What's that mean now? This value is negative, and looky right here. Delta G equals negative equals spontaneous. So that means this right here. Oops. This reaction was spontaneous. So it's like the ball on top of the hill. It's just naturally going to happen. Let's look at this next one here. We have the formula delta G equals delta H minus T times delta S. Now this is very similar to before, right? However, the enthalpy is now positive, and the entropy is now negative, so a little bit different. So I think the numbers are going to be similar, or are they going to be the same? Well, let's find out. Delta G equals the delta H, which I will be converting in my calculations, 10 to the 3, minus the temperature of 310 Kelvin multiplied by the enthalpy of negative 246. When I did the math out, I got a value of around 205 kilojoules. Alright, so now if you remember from before, we determined if delta G is positive equals non, if delta G equals negative equals spontaneous. So I'm just abbreviating here, I ran out of space there. So since delta G is negative is spontaneous and delta G is positive when not spontaneous, what is this reaction? Well, we notice we have positive 205. So since it's positive, delta G means this reaction, or this set of numbers, is non-spontaneous. spontaneous. Last one here for this session until we gonna make another video because of length. Now notice this time we have a negative enthalpy and a negative entropy in a positive temperature, Kelvin. That's fine. So this is a little same numbers as before, but different values for negative or positive. So let's write this out. We have delta H, delta G equals delta H minus T multiplied the delta S. So let's plug in these values. Delta G equals delta H. So in this case is minus 129 times 10 to the 3 minus temperature of what? 310 Kelvin multiplied by negative 246. Now if I have your attention real quick, be careful. Sometimes it'll give you a temperature in Celsius, and if you don't have your, say if the enthalpy and entropy are in terms of Kelvin, it won't work. It needs to be in every unit, all the units need to cancel out. So make sure that if it's in Celsius, just add 273 to it. Alright, enough of me. When I calculated this out, I got a value of minus 53 kilojoules. That is correct. Now, so what does that mean? That means it was spontaneous. Because negative value, because delta G is negative. So, this is the basics ideas of this chapter. I'll probably post the other few problems of this chapter later this week, because we'll let you guys catch up after class time. Well, if you have any questions, email me or let me know in class, and I'll see you guys then. Thank you.